Gohan's fight between Lavender was a really good fight in my opinion.
I don't think so, pal.
But what I like the most is how Gohan used his ki in a way that we today use sonar. So today in this video, I'm going to talk about how he actually did it. Now, before we continue, keep in mind that this theory is actually going to be based on a previous theory that was made from MatPat from film theory and game theory. See, a while back, MatPat actually made a theory about Dragon Ball Z, talking about how ki in the show is actually composed of plasma. It was a very interesting video, and if you haven't watched the video, I would suggest that you watch it now. But we're going to use his theory about ki being plasma within this theory as well. In fact, because of this episode, it actually gives another suggestion of ki actually being plasma. Now in the episode, Gohan uses ki in a similar way that bats uses echolocation or sonar. And how does echolocation work exactly? Well, bats emit a sound wave with a specific frequency, and they usually emit it towards certain objects, which specifically would usually be their prey. After that, the wave is actually reflected back towards the bat and is not the same as how it was transmitted in the first place. And it actually tells them where the prey is and how far they are. Now, to go more in depth, bats can determine the location of their prey by using what's known as the Doppler Effect. Now, the Doppler Effect is basically the change of the frequency of a sound wave due to the observer. For example, take a car that has a speaker. The speaker just blazing loud on the road and it's just driving past you. In front of the car sounds a lot higher, it has a higher pitch, while at the back it has a lower pitch. Why is that? Well, if a source of a sound wave is moving, the front of that sound wave in which it's moving will actually have a higher frequency, while at the back will have the lower frequency. So in this case, the front of the car has a higher frequency, that's why you hear a higher pitch, and the back of the car has a lower frequency, so you will hear a lower pitch. So if the bat's prey is moving towards the bat, if the bat were to use echolocation and have a high frequency, it will tell them, hey, the prey is coming towards me. Or if the prey is moving away from it and the wave coming back towards the bat has a low frequency, then I'll tell the bat also, hey, the prey is getting away from me. Also, keep in mind that the bats usually emit a sound wave that has a wavelength that's similar to the size of their prey in order to give a more efficient reflective wave. Because let's say if a bat is trying to look for a butterfly, for example, and it gives a wave that's bigger in length compared to a butterfly, relatively speaking, it's almost as if the wave is passing through the butterfly in that case. It's not going to be reflected back towards the bat efficiently. So now that we know what echolocation is, what is plasma? Now, plasma is a field that consists of electrons and positive ions, which are positively charged atoms, and they're separate from each other. Now, usually in science, whenever there's two different charges, they would, well, as the old saying goes, opposite attract, they'll actually attract to each other and neutralize that charge. It will eventually become stable and it will have no charge at all. But plasma is a special case because the electrons and the positive ions are separate from each other, and that's because plasma contains an electromagnetic field, which keeps them separate from each other. Now the question is, does plasma have waves? Yes. Waves and plasmas can be classified as electromagnetic or electrostatic. An electrostatic wave must be mostly longitudinal waves, while an electromagnetic wave must have transverse components or transverse waves in this case. Now you might be wondering, what the hell does that mean? Well, when we talk about waves, while many of them are similar to each other, there are mainly two types we look at: transverse waves and longitudinal waves. Longitudinal waves are actually associated with sound, while transverse waves are associated with light. Now, these two different types of waves are similar but different, and I'll tell you one difference. See, longitudinal waves exist on one plane of existence, while transverse waves exist on multiple planes of existence. What the fuck? Yeah, don't worry, I'll break it down for you. So, think of the graph that you usually see in math class.
Fuck this. Fuck. Did you see this? Look at this.
You know, the graph that has the x-axis, the y-axis, and then later on, once you go into college and you're doing like graphics and whatnot, you'll get the z-axis, which mostly associates with 3D objects. Those are different planes. That's light. Light is basically that x-axis, the y-axis, and the z-axis. While sound waves or longitudinal waves are just the x-axis or one of those axes, I guess. But you get the picture. Light exists on multiple planes, an x-axis, y-axis, z-axis, and so on, while sound waves exist on one. It could be just the x-axis, or the y, or the z, but it has to be one of them. Now the question is, does the key in Dragon Ball mostly associate with longitudinal waves or transverse waves? The answer is transverse. The reason why is because whenever you see the fighters power up, you do see the key around them. It's just sometimes when they're not really powering up, you don't see the key. But remember, light has many different degrees within the electromagnetic spectrum. See, light, as we can actually see it, is part of visible light, and that's a small speck on the entire spectrum, while the rest of the spectrum are parts that we can't see with our naked eye. Now, the light that actually comes from the plasma is due to electrons from the atom changing in energy levels. Now, if you don't know what an energy level is, think of the usual diagram of an atom. You actually see the orbits of the electrons around the core of the atom, which consists of protons and neutrons. The energy levels are the orbits around the core of the atom. But the thing is, electrons can change their orbit around that core, usually going higher up to an orbit that's more further away from the core, or an orbit that's more closer to the core. But usually when the atom emits photons, which, as we've discussed multiple times before, is a particle of light, usually the electrons are actually changing energy levels, which results in the emission of photons. For plasma, like I said earlier, there's electrons and positive ions are separate from each other. But at the same time, there's still some electrons within the orbit of the atom. It's a little confusing, but hear me out. Think of it this way. Atoms usually have more than one electron. The only atom that has one electron would be a hydrogen atom. But other than that, all the other elements have multiple electrons. So for plasma, you could think of an atom that has half of their electrons separated from it. So those electrons are within the plasma field, while the other half of the electrons are still within orbits of the atom, but changing in energy levels, which results in the emission of photons. But here's one final thing. Remember earlier when I said that bats emit sound waves that have the wavelength that's similar to the size of their prey? Well, for Gohan's case, that wavelength is going to be much larger. So we can actually try to determine which section of light that Gohan actually uses and what Dragon Ball Z characters use in general. Now we're just going to use an estimate here. It says here that the average American height for men is 177 centimeters, which is 1.7 meters. And according to the diagram shown here, a wavelength that will be mostly associated with that height is here, 1 meter, which is associated with radio waves, which is used in TVs and radios and etc. That actually makes sense. But then here's something that you really have to think about. Earlier I said that whenever the characters power up, you actually can see the key around them, so it's part of visible light. Visible light is right up here with a much smaller wavelength. So wouldn't that contradict what I said earlier? Kind of, but I have an answer to that too. See, as you go up within the diagram, the energy of the waves increase along with its velocity. As in, the speed of the waves increase, it's moving faster. Think about it. In battle, Lavender is going to move pretty damn fast, and Gohan needs to react just as fast, even faster. So he needs the waves to bounce off of Lavender at a fast speed in order for him to figure out where he is at a quicker pace. So this would mean that the wavelength of the key being used by these Dragon Ball characters can have a wavelength about visible light standards at its highest point, while at its lowest point, it could be at the radio wave standpoint. That's the range in which the key is being used by these characters. So let's review. As Lavender started flying, he was at a larger distance compared to before, so Gohan was having trouble detecting him. Because of this, Gohan had to power up in the Super Saiyan form, which has a wavelength that is equivalent to visible light. This enabled the waves to be reflected back to Gohan at a faster rate, allowing him to react to Lavender's attacks at a faster rate as well. So I hope you enjoyed the video. Hope you guys have a good day. Peace out.